Hello friends, this is your friend Vidushi. I'm back on the channel Step Up with Vidushi Medico. This time the video is on biological oxidation and electron transport chain. I know electron transport chain, this topic is difficult for I think almost everyone. For me also it was difficult once. So I'm here to explain you this topic very nicely. Please watch the video till end. Okay guys, so I have a request for you, all of you. Please subscribe the channel Step Up with Vidushi Medico. I am working really hard in making these kind of educational videos, so please subscribe the channel. Okay, so you can see NAD plus Link Dehydrogenase over here. NAD plus is derived from nicotinic acid, which is a member of vitamin B complex, and NAD plus is accepting two electron here, as you can see on the double sided arrow. Two electrons and an hydrogen atom is written over there. So when the NAD plus accepts the two hydrogen atoms, one of the hydrogen atom is removed from the substrate. As such, the other hydrogen atom is split into one hydrogen ion and one electron. The electron is also accepted by the NAD plus so as to neutralize the positive charge. Now let's begin with the complexes. Since complexes are the most important part of electron transport chain, the complex that you can see right now on the screen is electron transport chain complex 1. It is also called NADH co-Q reductase or NADH dehydrogenase complex, and it is tightly bound to the inner membrane of mitochondria. It contains a flavoprotein consisting of FMN as prosthetic group and an iron sulfur protein NADH is the donor of electrons. See, FMN accepts them and gets reduced to FMNH2. If it is accepting hydrogen, then after addition of hydrogen it will become FMNH2 only, na? So two electrons and one hydrogen ion are transferred from NADH to flavin prosthetic group of the enzyme. The electrons from FMNH2 are then transferred to FES. The electrons are then transferred to coenzyme Q, that is ubiquinone. This is the most important step. You have to remember this, that the electrons after acceptance of FMNH2, they are transferred to ubiquinone. Ubiquinone is the electron acceptor here. Now I hope that complex 1 is clear to you all. Now let's move on to complex 2, that is also known as succinate Q reductase. Now the reactions in complex 2 is represented here only. You can see in summary, succinate is given, it is getting converted to FAD, then it is getting converted to FES, and then what is that? It is transferring its electron to ubiquinone only. Okay, coenzyme Q. So now see, ubiquinone, that is having a ketone group. It is accepting electrons, so it will get reduced. So ubiquinone is reduced successively to semiquinone first and then finally to quinol. It accepts a pair of electrons from NADH or FADH2 through complex 1 or complex 2 respectively. Since I have told about this in complex 1 also and in complex 2 also. So till now we have done complex 1 and complex 2. Now let's move on to the another complex, that is complex 3 or cytochrome reductase. Now this is not a simple complex, okay? This is a cluster of iron sulfur proteins, cytochrome B and cytochrome C1. Both contain heme prosthetic group. Now the sequence of reactions you can see here on the screen, very nicely it is given. Okay, so here you can see that the electrons from ubiquinone are transferred to FES, then cytochrome B, then cytochrome C1, and then finally to cytochrome C. Now cytochrome C is a peripheral membrane protein that contains one heme prosthetic group. Now we come to complex 4 or cytochrome oxidase. it contains different proteins including what all? Cytochrome A and cytochrome A3. The complex 4 is tightly bound to the mitochondrial membrane. Now the reaction here also you can see that the cytochrome C, which was a peripheral protein, it is transferring electrons to cytochrome A3, and then finally oxygen is the electron acceptor. Now after electrons are transferred to oxygen, so 2 protons are pumped out to the intermembrane space. You must remember this, that the electrons, no, not the electrons, but the protons are pumped out to the intermembrane space. Now let's come to the last complex. That is actually not a complex, but yes, we can consider it. That is complex 5 or ATP synthase or proton pump. Now the proton pumps complexes 1, 3 and 4 expel H plus from inside to outside of the inner membrane. So there is high H plus concentration outside the inner membrane. This causes H plus to enter into mitochondria through the channels F0. So as you can see, the lower part of the thing that you can see here on the screen, the lower part is actually F0, and the upper part that is made by alpha beta, that is the F1 part. Okay, now we are done with the complexes, all the complexes, complex 1, 2, 3, 4 and 5, that is ATP synthase also. In this diagram, in this table, the summary of all the complexes is given, how the electron is passing. As you all can see, there is site 1, 4 protons are pumped out. Now these 4 protons have come from where? From complex 1. So this was all about electron transport chain complexes that I have talked about in this video, and about the explanation how the electrons are transferred from one complex to another. I will explain them in my next video. Please stay tuned, and please subscribe the channel Step Up with Vidushi Medico. I really want to increase my subscribers, so please do that for me. And let me tell you, my next video will be on how the electrons are transferred from one complex to another, how are the ATP generated in electron transport chain, and that will be electron transport chain part 2 video. And please like, subscribe and share the channel Step Up with Vidushi Medico. Thank you so much for watching it till the end. Thank you so much.